Welcome everyone. I see some familiar faces here. Some of you may already know me. I've been doing this for a while, worked on on-prem for quite a bit of time, wrote multi-site design guide, worked on a lot of the multi-site disaster recovery stuff. My name's Humair. I'm a senior technical product manager within the network and security business. And I focus specifically on all the networking and security in VMware Cloud on AWS. So today in this section, we're going to focus on the networking and security capabilities offered by NSX and VMware Cloud on AWS. And when you look at the features, first of all, some of you may already know the platform in VMware Cloud on AWS for networking and security is NSXT. Okay, we made that switch over, a few months ago. Prior, when we launched the service, it was based on NSXV. Now the underlying platform is an NSXT. And if you look at the features and capabilities, you can really group them into three categories. There's networking and connectivity, things like route-based VPN, IPSec VPN, all traffic over direct connect. There's security, things like distributed firewall, security groups, security tags, role-based access control. And then there's also operations, things like port mirroring, IPFix, and APIs. Obviously, we have 30 minutes here. We're not going to go through everything. It's not going to be like a deep dive. But what I do want to focus on is some of the important aspects of the networking, connectivity, and security. Okay. So before we get into some of the specifics about connectivity, I just want at a high level want to explain some of the architecture here. So when you look at the VMware Cloud on AWS SDDC, we have a router here called Compute Gateway, a router instance called Compute Gateway CGW, and all the logical networks are attached to the CGW where the compute sits on. And this is where customers are really concerned with. They're deploying their workloads. They get deployed on these logical networks that are attached to the CGW or Compute Gateway. There's also another router instance called MGW. Now behind this, the management components like vCenter sits behind, and this is what VMware manages, and customers not really concerned about managing or deploying things here. They're deploying workloads behind the Compute Gateway. Now, you'll notice there's another router connecting the CGW and MGW, okay? And in NSXT terminology, this router is called a Tier 0 router. And this Tier 0 router is where all the connectivity to the external world terminates. Think whether it's internet, going out the internet gateway, direct connect, VPN, it's all terminating here on the Tier 0. Now, the CGW and MGW here are a Compute Gateway and Management Gateway. These are in NSXT terminology called Tier 1 routers, okay? And these Tier 1 routers are basically, as I mentioned, the Compute Gateway is where the compute workloads sit behind, and MGW is where the workloads sit behind, and they're connected to that Tier 0 for communicating out to the external environment, whether that's internet or whether that's on premises. Okay. Now, these Tier 1 routers have a distributed component across all the hosts, and they also have an edge component sitting in an edge appliance. And then we have this edge appliance running in active standby mode for resiliency. And now here, there's different connectivity options we offer. We've had policy-based IPSec VPN for a while. Now with NSXT SDDC, we have route-based IPSec VPN, all traffic supported over direct connect as well. We also still offer L2 extension with L2 VPN. And then we also support this new thing that AWS announced at reInvent last year called AWS Transit Gateway. I'll talk about that here as well. Okay, so really quickly, I just want to kind of show what's possible here with VMware Cloud on AWS with all these features and how customers use this. So here, I have an on-premises data center environment, and here I have my VMware Cloud on AWS SDDC. Customer here has this hybrid cloud connectivity through Direct Connect for their hybrid cloud solution, right? And then they also have connectivity to connected VPC with this technology that AWS VMware created together. It's kind of integrated so they can communicate to native AWS workloads directly from this SDDC, okay? So they can access things like EC2 instances, S3 buckets, and I believe R3 from AWS is there. She's going to go into that in a bit more detail as far as the connected VPC side. Okay. So here, what can customers do? Well, once they have this hybrid cloud connectivity here. With Direct Connect, they can access managing components like vCenter over this Direct Connect. They can also communicate from workloads on-prem to workloads in the SDDC over this Direct Connect, this high bandwidth, low latency connection. Then they can apply security policies directly on these specific interfaces like Direct Connect. They can apply security policy on that Direct Connect interface. I'll show you that in a demo later on. They can also do things like communicating, obviously, on the same tier or between tiers. Workloads can communicate in the SDDC. You can also use distributed firewall here and enable microsegmentation capabilities. You can also communicate to these S3 buckets, EC2 instance native AWS services, and apply policies directly on that interface as well. And then you can also do advanced things like port mirroring and mirror traffic to something like a Wireshark, right? So just a quick snapshot, like of how robust this platform is and some of the capabilities. Questions?
After you.
So as mentioned earlier as a roadmap item about multiple CGWs, so presumably the current architecture here is that CGW is in the first cluster in an SDDC, and then all subsequent clusters in that SDDC use that CGW as it stands at the moment.
Yeah, so there's, like I said, there's a distributed component. I mean, this is the CGW is an NSX terminal T1 router. There's a distributed component to that, and then there's that edge component. And that edge component is what has some of the, maybe edge firewall and, edge services and external connectivity to it.
And that's what lives in?
On one of the hosts, right?
In the first cluster?
Yeah, I mean, it'll be in a cluster, right? And like a management resource pool.
And so how does that change with that roadmap item about having multiple CGWs?
Yeah, I mean, that's a roadmap item, so I'm not, that's something like I'm not gonna get into here, but like, yeah, we're looking at, eventually you'll see this model kind of expand out and additional options available.
And at the moment, because you're connecting the ENIs to the first cluster in an SDDC, if you're connecting to native services, additional clusters have to route via the...
Yeah, there's some internal routing that takes place. There's ENIs on every host, but there's some internal routing that takes place.
On every host in every cluster?
Yes, there's ENIs on every host.
In every cluster in an SDDC?
There's on every host. It's like regardless of cluster, there's ENIs on every host.
Okay.
Okay. Any other questions? Okay.
How does that handle stretched cluster in terms of that CGW? If that availability zone...
Yeah, so it's going to be, so it'll be on one availability zone. Mm-hmm. If there's AZ failure, it'll fail over to the second. vSphere HA will kick in, bring that up on the second AZ.
Okay.
And keep in mind, there's active and standby edge too. So there's lots of resiliency built into this platform. There's active and standby. And then there's also, like you mentioned, you can also have this multi-AZ capability. If there's AZ failure, they can come up on the second AZ.
So the ENI that's placed in my real AWS VPC, can that ENI be used as along with a standard S3 endpoint, for example?
Sorry, I didn't. You can use S3 endpoints and use this ENI.
You can use S3 endpoint.
Yeah, I mean, in your native VPC, and then you can use this ENI connectivity to access that.
So the API connection, say to S3, goes over the endpoint, goes out from the additional ENI to the endpoint.
Yeah, exactly.
Okay.
You could have like an endpoint running. I mean, how we're using the EC2 and S3 and so on. Okay. So yeah, I want to make it clear here. The edge is on one host. There's ENIs on every host. That edge could come up on another host, and the ENI that's used to access that, there's only one ENI that's active. That's the one the edge host, the CGW is on, or the edge appliance is on. That's the one that's active. Okay. Now, if that edge were to move, then the ENI on another host would get used. But there's ENIs on every host with one ENI that's always active.
Sorry, just if the edge is only on the first cluster, how can you have ENIs being used from other hosts in other clusters in the same SDDC? So
what I'm saying is, like, the edge is going to be on one host, right?
In the first cluster.
And let's just stick with one cluster to like simplify it first, but it's going to be on one host on that cluster, and that's going to be the active ENI. Now there's some internal routing. It'll always use that ENI connectivity from that edge to go over to the connected VPC.
And can I connect to multiple VPCs, or I'm just in the cloud customers AWS?
So here it's a one-to-one relationship. So from the SDDC you can connect to one. Okay. Okay, so a lot of questions, more than I expected, but that's good. I'll just have to keep a watch on the time here. I tend to put a lot of slides in here, which is good, but feel free to ask questions along the way if something's not clear. Arthi will go over the connected VPC in much more detail if you have more questions around that as well. So here now, I want to talk about the route-based IPSec VPN, and then I'll talk about some of the direct connect and security and so on. Now, route-based IPSec VPN is something we introduced with NSX SDDC first. Before, we only had policy-based IPSec VPN. Okay. Now we support route-based IPSec VPN. So what customer can do is set up IPSec VPN to their on-premises environment. Then what they can do is set up this virtual tunnel interface on the SDDC, and then they can run BGP using this VTI. So they're doing BGP over the route-based IPSec VPN. So networks are automatically learned from the SDDC and from vice versa from on-premises. Okay. Now, using this route-based IPSec VPN, you can also get additional resiliency because you can just set up an additional VTI interface, and you can now use BGP to say, okay, BGP metrics on-prem to say, okay, which tunnel's active and which tunnel's standby. So you can get this additional resiliency using route-based IPSec VPN. And one thing to note here is we provide both a private IP address and a public IP address on this tier 0. So for example, you can use the public IP address and do route-based IPSec VPN over internet. Or you could use the private IP address and do route-based IPSec over direct connect. There's reasons you may want to do that. I'll talk about that in a minute. Okay. So once this route-based IPSec VPN is set up, entire VPC CIDR is advertised on-prem, management appliance network, NSX network segments are advertised automatically to on-prem, and then from on-prem you can advertise specific subnets, or you could even advertise a default route. And we tried to make it very easy to configure this and get going with a route-based IPSec VPN. You select the local IP. As I mentioned, you can select public or private, depending on what you're trying to do. Put in the remote IP, create the VTI interfaces, and put in the configuration, and you're good to go. And we also provide statistics. So if you're having an issue, you can kind of see here and look at the statistics, traffic going over this route-based IPSec VPN. And more recently, we added this capability in route-based VPN where you can look at what routes are being advertised from the SDDC, and then you can click this other tab, Learned Routes, and see, okay, what routes am I learning? So you can see here I have a VPN to the AWS Transit Gateway I'll talk about later, and you can see these are the networks I'm advertising to the TGW, and then if I click the other tab, you can see the routes I'm learning from the TGW. So very useful for customers. Okay, so Direct Connect. Direct Connect, is a very good option for this hybrid cloud connectivity, high bandwidth, low latency. And now with NSX SDDC, we can carry all the traffic over Direct Connect, vMotion, ESXi management, workload traffic, management appliance traffic. So you don't need any VPNs. You can just set up this Direct Connect, carry all the traffic over it. And we automatically advertise, the infrastructure subnet. So you could do things like vMotion. We advertise all the NSX network segments. And all of this is advertised automatically on-prem. Then from on-prem again, you could advertise specific subnets or a default route. So once you have this Direct Connect set up, there's a lot of flexibility and a lot of things you can do with this, right? So here I'm under the Direct Connect section. So you can see here I have 2 WIFs created. There's not much you need to do on the VMware Cloud on AWS side, right? You go into the AWS console, you create a hosted WIF, and then you come here and you give it the AWS account that your VMware Cloud on AWS SDDC is using. Now all you have to do in here is come and accept the WIFs. And you can see here I've accepted 2 WIFs. I have 2 WIFs that are currently being up and active and currently being used, okay? Now you can also come down here and see the routes that are being advertised from the SDDC to on-prem via the Direct Connect. Again, that's going to include workload subnets, infrastructure subnets, and then also the routes I'm learning from on-prem. This could be specific subnets. It could also be a default route. And what we did is, what we're transitioning to now is, we're giving customers the option to edit this ASN, BGP local ASN, so they could actually use a private ASN. And going forward for all new orgs, and eventually we're transitioning so customers will use private ASN. For all new orgs, the private ASN is default. It's a private ASN. What is it? 64512, something like that. It's a private ASN that's used, and customer can edit that and put their own ASN based on their design. Okay, and then you can also see we provide additional information here for troubleshooting purposes. They can see what the remote endpoint is, the remote IP. They can see the remote ASN for those specific WIFs. So once they have this set up, what I was mentioning, there's a lot of flexibility they have. They have this direct connect for their hybrid cloud solution, and they can now access the managing appliance like vCenter from on-prem over this direct connect. And they can put in security policies in place to control who can access that. So here you could see the management gateway firewall. I have specific firewall policy under source. I created a security group called on-prem, and this is basically my on-prem subnet. And the destination is a security group that's created by default for vCenter. And you can see I'm allowing specific types of traffic over that direct connect. Customers also have flexibility with design. There's a lot of things they could do here. In this case, like customer may want to advertise a default route from on-prem. By default in the SDDC, these workloads, the default route for internet is out the AWS Internet Gateway. Customer may want to do something like say advertise a default route to the SDDC, so all traffic goes back over direct connect to the on-premises data center to go out the internet. They may want to do that, if they have some security appliances, some hardware devices sitting on-prem where they want all the traffic to go through and they don't want any internet access directly to the SDDC. So there's a lot of flexibility here for these solutions that customers can design around. Let's say customer is a requirement. Another thing customer can do here that sometimes will come up is they say, okay, I want to encrypt traffic because Direct Connect doesn't offer this native type of encryption, right? So some customers have a requirement, okay, I want to encrypt all traffic going over Direct Connect. Well, as I mentioned, we have that private IP address as well. So now this tier 0 has a private IP address. So if you have this Direct Connect established, you can create a route-based IPSec VPN over this Direct Connect, and now all your ESX management vMotion traffic will go over the high bandwidth, low latency Direct Connect connection, and your compute and management appliance traffic will be encrypted over this route-based IPSec VPN. You can see a lot of things that are possible in terms of design based off the foundational platform features that we're offering here. Okay, so now based on this connectivity that I just showed, you can come up with much more complex, designs. So for example, here I have NSX SDDC, it's connected to the connected VPC over that ENI functionality we talked about. And customer also has direct connect to their on-premises data center, okay? Now, customer may want to deploy another SDDC here and use route-based IPsec VPN to connect to it, right? So now why may they want to do this? Well, maybe they just have services there they need to access or workloads that they need to communicate between the SDDCs, or maybe they even want to do disaster recovery from SDDC to SDDC, right? You can do disaster recovery from on-prem to SDDC, you could do disaster recovery from SDDC to SDDC as well. They may also have a requirement to do connectivity to native AWS VPC. Okay, they can also do that. Perhaps they have services they're running. So you can see, based off some of the foundational connectivity options we offer, you can come up with very complex and elaborate designs. And you can also create this environment of kind of any-to-any kind of communication, one-to-many communication, a lot of different things possible here. And this is where AWS Transit Gateway can come in useful too for some of these designs when you want to do, for example, like any-to-any type of communication, or say you want to share a VPN connection to your on-premises environment between multiple Leaf, VPC, and VMware Cloud on AWS SDDCs. So in this example, customer will say deploys a Transit Gateway. Now they connect Leaf AWS VPCs to this, okay? And they can also use VPN attachments here to connect the VMware Cloud on AWS SDDCs. Okay, so now just with this, you could see I have, this kind of any-to-any communication. Sorry, going through this transit gateway.
Can I just ask?
Sure.
This is so. If I have multiple SDDCs, there's no. By default, there's no connectivity between those SDDCs, even in the same region. I need to put this sort of design in place for communication between those two SDDCs.
Yeah, good question. Yeah, when you get an SDDC, one of the main things that we do that, customers are always looking for the security. That SDDC, although it has all the options and flexibility there, like even to internet, you have, by default, all the workloads of source NAT configured so they can access that internet, but the edge is blocking, any communication into that SDDC. But the source NAT is there. All you have to do to allow that internet access is, allow that traffic through the edge firewall. Same with any other type of connectivity. There's no connectivity by default. Once you deploy SDDC, things will start talking to anything, whether it's another SDDC, whether it's internet, or whether it's on-premises environment. Customer has to go and can make that connection or allow it through the firewall. Okay.
But so within a single SDDC, if I add additional clusters, then they can all talk to each other, the VMs in those clusters. But if I add another SDDC, that comes into that remit where you're saying you can't. The SDDC is the bubble of where you have to enable, explicitly enable communication.
Right. You can kind of think of it as a VPC in native AWS, right? Because at the end of the day, each SDDC is kind of using VPC, right? So you can kind of think of it like that. Now, within the SDDC, there's security configurations. For example, we have the additional add-on, the DFW, right? By default, that's set to allow all. On the edge firewalls, the default, that's where customers are more concerned because that's to the external environment. The default is deny all. Okay.
So are the VMware Cloud bubbles connected to the Transit Gateway via IGWs in the VMware bubble?
Yeah.
I'm trying to understand a little bit more about the VPN attachment requirement for the Transit Gateway.
Yeah, sure. So Transit Gateway in general, right, offers basically different types of attachments. Like for their native VPC, they have this VPC attachment, right? There's no VPN. And based on what type of attachment, there's a lot of detail I won't go into, but based on what type of attachment you're doing, the behavior can be slightly different. Okay. Now on the AWS side, you're basically using the VPN attachment. And this VPN attachment means this router is basically creating a VPN tunnel to the Transit Gateway. Now the Transit Gateway sits at the regional level, right? So you're creating a VPN, from this router, from the tier 0 router of the SDDC to the regional construct Transit Gateway. Okay. Now in the future, you'll see additional things and additional capabilities that we're going to, that we're looking at. I can't, talk about them obviously in detail, but you'll see additional things there. But this is cool because there's lots of things customers can do. They can, even without Transit Gateway, you could use VPNs as I showed to connect SDDCs together, and you can come up with very intricate and complex designs. There's a bit more work involved because you're doing a lot of manual stuff. The idea of this Transit Gateway is it's really replacing, if you guys are familiar, some of you may be familiar with Transit VPC, AWS Transit VPC designs. This is replacing the routing Transit VPC design where customers are using that Transit VPC for routing, where it's routing everything to that Transit VPC hub, going to all the different VPC or SDDC spokes. Now customer can just deploy this regional level Transit Gateway construct, connect everything to that, and you can get this any-to-any communication.
This is supported at the present state?
Yes, yeah. Everything I'm talking about today is supported. I'm not talking about any roadmap items. So you could get this any-to-any communication. And then the other benefit here is I could have one connectivity, like VPN attachment connectivity to this Transit Gateway. And I could share this connectivity now to all my spokes, whether it's VPCs or SDDCs. And you can see this is a VPN attachment. Now, AWS announced that reInvent, that they're going to eventually, I think it's going to be sometime soon. Maybe Arthi can talk about it later, but they're going to support direct connect to this transit gateway as well. So right now I'm showing this VPN attachment. There's also other designs that are possible. If customer just wants to do, say, VPN attachments, or just wants this any-to-any communication between SDDCs or even VPCs, they don't necessarily have to have this connectivity to on-prem. They can just use transit gateway so all these spokes can talk. And perhaps like one of these guys can even have direct connectivity here, instead of connected to the transit gateway, where these guys are accessing the direct resources on-prem, but they're also accessing other resources through the transit gateway. It's different things you can do. A lot of flexibility.
I'm sorry, one question. Will there still be, say, a VPC that's not shown here, that when you build the VMC on AWS, you make like that ENI attachment?
No, there's things in the back end, but the customer doesn't see any of that. I mean, they get this SDDC and this console, and our thing is we want to simplify a lot of things.
Are there any special considerations around route propagation or anything I need to avoid that would potentially lock you out, or are you keeping all?
Yeah, I mean, you have to be careful, right? It's just like anything else with routing. Like you don't want to advertise, you don't want to have overlapping, networks and things like that.
I meant more from a locking VMware out of it. So, like, could I make a mistake that would then take away your management?
No, not that I can think of, because you're accessing this through the portal.
Yeah.
So through the portal, you can access and enable and remove any policies, right? So you should be good because you're accessing this. Remember, just like AWS console. Think of it like that. You're going through the VMware Cloud on AWS console, and there you can lock out someone from vCenter, but someone has access to that. They can go there and then enable it again, right? Okay, I kind of slowed down a bit because I saw I had some extra time, but then the questions started rolling in. Now I'm behind again. So I was watching the time. I'm like, I'm going too fast. I'm going to finish. I slowed down a bit, and now I'm like, okay, behind. So L2 VPN, we offer this L2 extension capability too. And customer doesn't have NSX on-prem, they can deploy an appliance, NSX appliance. They can do this L2 extension where the server is running in VMware Cloud on AWS. So you can see here in the console, I have a server running, and you can see this remote IP is basically the client appliance. On the on-premises data center, you can see I'm extending, an L2 domain here. And Gateway's on-premises router for this, and customers what they'll do is they'll migrate workloads, to keep that same IP addressing, and then from the console, they can go in there and switch that extended network to a routed network, okay? And once they do that, the gateway becomes in the SDDC. Let me speed up here because I want to make sure I get through the demo here. So I want to talk about security. I talked about quite a bit about the connectivity. There's a lot of security capabilities that NSXT brings to the table as well for VMware Cloud on AWS, starting with grouping objects. You can create these grouping objects, basically security groups that can be based on different criteria, like IP address, for example, VM instance, where you're selectively selecting which VM is in that grouping object. You could base it off VM name, say all VMs that start with WEB, automatically put them in this security group, right? You could also base it on security tags. Say all VMs that have the security tag, automatically put them in the security group. And then I can use those grouping objects in my security policies, right? Now, these security policies can be on the edge firewall, or they could be on the distributed firewall. So here I'm showing the edge firewall, CGW in particular here, where I can now take those grouping objects, those security groups, based on that different matching criteria, and apply them to specific interfaces, okay? Whether it's internet, VPN, direct connect, or the connectivity, ENI connectivity to the native VPC, okay? Now, I can also take the grouping objects based on IP address and apply them on the MGW firewall to control access to my management components or vCenter. Okay. Now, I can also take those grouping objects and use them in my security policies with the distributed firewall, which is providing that microsegmentation capability, right? So here I can do microsegmentation within the same L2 network, or even across different tiers, right? And this microsegmentation capability is very useful for customers to create these multi-tenant kind of environments, more secure environments. Obviously, no overlapping IPs right now because you're still connected to the same CGW, but you can create isolated networks like prod, test, and dev using this microsegmentation capability. Okay? And important thing here is customers can now migrate their workloads to the cloud and take advantage of these same security policies and this advanced security that they may be using with NSX on premises. Or if they don't have NSX, for the cloud, they can take advantage of these more advanced security policies.
Two questions. Where do you store your security policies? And second, is it possible to export them to have the same on-premise or in another region?
Yeah, so everything is done through the console, and we've simplified it a lot. So DFW policies, MGW, CGW policies, everything's done within the console. You can go there and edit the policies. And you can give auditor access so people could just view it, or you can give read-write access to certain people within your organization. And as far as like the security policies, there's APIs available. So because we're using NSXT as the underlying platform, the nice thing is whatever you have on-prem, you can leverage these API policies to kind of recreate what you have on-prem into SDDC using security groups, security tags, and so on. And in the future, you're going to see more advanced things coming down the line for that more converged kind of hybrid cloud story. A lot of things you can already do. In the future, we're going to keep building on that. So let me run through the demo here. I'm going to make sure we get through it, and then I'll take more questions if we have time. So in this demo, I want to kind of touch upon everything I just showed, probably answer some of the questions as well, if you want to know like where do you actually go to do this, or where are things stored. But here, what I'm going to do is from on-premises data center, I'm going to access workloads in my SDDC. And then I'm going to apply a policy on that direct connect interface like I showed in that animation earlier to deny that traffic. Then I'll communicate between workloads and SDDC. I'll use DFW to showcase microsegmentation. Then what I'm going to do is I'm going to have these workloads communicate to workloads in another SDDC to highlight this transit gateway capability. And also, these workloads, I'll have them access EC2 instances running in native AWS VPC as well to show how this transit gateway can be used with VMware Cloud on AWS. Okay. So here you can see this is my SDDC, VMware Cloud on AWS SDDC. Here I have my MGW, here I have my CGW. You can see I have connectivity to the internet, connectivity to my on-premises data center, and connectivity to that connected VPC where I have EC2 instances running. If I click Direct Connect, you can see I have these two private WIFs created, Direct Connect private WIFs created and established. They're currently being used. And then you can see these are all the networks, infrastructure, and workload subnets being advertised, and these are the routes I'm learning from my on-premises data center. Now, if I come up here and I click Groups, under Management Groups, you can see there's a vCenter group that's automatically created. And then I created this on-prem group with my on-premises subnet for workloads I want to use to access this vCenter. So here you can see under Management Gateway, I created a policy restricting who can access this, my on-premises security group to my vCenter. So here's my on-premises IP address for a workload I have running in my data center. And if I click Open vCenter here, I can click Show Credentials, Access vCenter. I'm just going to close this here because I already have a tab running here just to save time. You can see this is my vCenter. I'm accessing it over that Direct Connect. Now, if I go back to my grouping objects here, my workload groups, or my virtual machines here, you can see I have two web VMs, and I have web security tags assigned to them. Okay? And then under workload groups, you can see I created a web security group matching on that security tag. And if I click View Members here, you can see those two web VMs are members, right, based on that security tag criteria. And then I also have an on-premises workloads group based on my subnet on-prem. Now, if I go back up here to my compute gateway, this is for the workloads. I have two rules created here, on-prem to web, and vice versa. Over the Direct Connect interface, I'm allowing that communication between my web VM and the SDDC and my workloads on-prem. Okay? And here, if I go under segments, you can see there's my web network segment. Here's my web VM running in that first SDDC. You can see its IP address there. And you can see it's on that web network segment here, that web logical NSX switch. Okay. So here for my on-premises VM, you can see it's in that on-prem subnet. You can see I'm just going to do a continuous ping to that web VM. You can see it's going over that direct connect that's working. Now, what I'm going to do is go back to my console for my first SDDC here, and I'm going to go to that firewall for the compute gateway here, and I'm just going to change that allow to deny for this direct. You can see I'm applying it here to the direct connect interface. I'm just going to change this to drop. Okay, and when I publish this, if I go back to my continuous ping there, you can see, right, that communication is now no longer possible. Okay, so here I'm going to go to my distributed firewall now, and you can see I created a rule here using the web security group, just web to web, right? So they're on the same segment, I'm allowing it. What I'm going to do is go back to that web VM, that same web VM I used in the SDDC. You can see it's the same IP address. And here's a second web VM on the same network segment. You can see one's .1, the other's .2. And I'm going to go to my first web VM here. And I'm just going to do a continuous ping to that second VM. Okay. So I'm doing continuous ping here. You can see that communication is good. And what I'm going to do is just go back, and now I'm going to edit this and just drop that. And this is really showing that microsegmentation capabilities. Even the workloads are on the same network segment, I can use this to isolate those two workloads from each other. Right? You can see that's the expected result. Okay, so now what I'm going to do is go back to my first SDDC here. I'm going to click VPN, route-based VPN. You can see I have two VPNs established to my Transit Gateway, AWS Transit Gateway here. Now, these are in active standby mode. I'm going to click in network segments. I have a number of network segments. Notice this first web network segment, starting with 10.72.31. I'm going to go to my second SDDC, and here under route-based VPNs, you can see this SDDC also has two route-based IPSec VPNs established to the Transit Gateway. And I have a number of segments here. Notice this web network segment, 10.61.41. Actually, the first SDDC, I wanted to mention the app network segment. But here, this is the Transit Gateway that's created in AWS. And you can see I have a number of attachments. I have an attachment to both of my VMware Cloud on AWS SDDCs, and I also have attachments to two of my native AWS VPCs. And if I go under Transit Gateway route table, you can see I have routes to that web network segment in my second SDDC. And this is the route to my first network segment in my first SDDC. That's the app network segment I wanted to actually show. And then I have two network segments here two subnets here to my native AWS VPC. Okay. And notice the attachment type for the SDDCs is VPN. So I'm going to go back to my web VM. And then I'm going to go to my app VM here in my first SDDC. So this is the app VM, my first SDDC, and I'm going to communicate to the web VM in my second SDDC over that Transit Gateway. And you can see this communication is possible. This is basically that any-to-any communication. And now what I'm going to do is, you can see in this VPC, I have a VM, 172.32.32.4. This is my native AWS VPC in VPC1. And from that same web VM, I'm going to ping that IP address of that EC2 instance running my native AWS VPC. You can see that communication is also good. So all this communication, whether it's to an SDDC or native AWS VPC, is going over this Transit Gateway. And now if I go back to my first SDDC under route-based IPSec VPN, you can see I can view routes and download routes here. I can click view routes here, and I can show you the advertised routes, right? You can see this is my app network segment for my app VM I just showed you that's being advertised. And then under learned routes, you can see I'm learning the web network segment from my other VMware Cloud on AWS SDDC. And I'm also learning these two subnets from my native AWS VPCs. Okay, so very cool stuff using this Transit Gateway, enabling this any-to-any kind of communication model. That's really the end of my presentation. There's a lot more links here you can reference for more information.